Hey, welcome everybody. We are really glad and excited to have you folks here today. This is week number 2 of our machine learning study jam, and we are super excited to have a guest speaker with us today. We are recording this session, and we're going to be posting this session to our GDG Oahu YouTube channel. So please feel free to drop over there, like our channel, subscribe, whatever. And hopefully you can share out our video with your friends also so that we can help grow our learning community. It's just a minute after the hour. I know there's not a lot of folks online, but hopefully more people will be joining us soon. And then again, of course, we're going to have other folks in the chat. But I'm really excited to welcome a special guest that we have today. Maddie, hi, thanks for joining us today. If you want to pop in, turn on your camera, we would love to have you introduce yourself to folks here today. Thank you so much for being here.
Hey, thank you so much for having me here. I hope you can hear me okay. I was just saying earlier to Krista that I really appreciate people who take the initiative and are motivated to organize these events because it benefits a lot of people, and I basically just show up for the fun, right? But my name is Maddie Shang, and I am a research engineer slash researcher. I work in the industry, but a lot of my machine learning work actually has to do with open source as well. So I lead a lot of open source projects. Yeah.
Awesome. And we just got a message from someone in our Slack channel that said that they were having trouble getting in. So let me just
Oh,
update
okay.
that as well.
I saw your concerned face. I'm like, oh, is my audio not working?
No, you're good. You're good. Somebody just said, this is taking me to the wrong event. And I'm like, okay, let's try this link instead.
Yeah, it's all good. But yeah, so basically, I started as a self-taught web developer, and then as I was navigating through the industry of tech, I realized that two things were probably going to be pretty big and pretty interesting. So one of them is blockchain, and I did a little detouring that. I became a blockchain developer, and then I started to see maybe the industry getting a little frosty. So then I'm like, okay, let me try AI next because I feel like that's more substantial, actually productive. So I kind of ramped myself up on machine learning, and I've been doing that ever since. So it's been lots of fun.
Oh, okay. Um, so let me backtrack just a little bit. Tell me a little bit more about, where in the world you are right now.
Yeah.
What was your journey like, I guess, to, career wise, how you got to this point? What is it that you're doing now?
Yeah, really good question. So let me start with the first one. I am what people would call a digital nomad. I basically live out of my truck and I work out of my truck. In many ways, the pandemic I think was like a horrible thing, but also exposed many opportunities. For example, for productive remote work, right? So I'm very blessed to be able to do that. Right now, I'm in Alberta, Canada, and that's why you see many animal related things in the background a little bit. What am I doing now? So I work on a machine learning team in in industry. I'm not sure if I can disclose who I work for because I didn't clear this event by
That's fine.
my work, but I work on taking machine learning research and hopefully getting it all the way into production. And the whole idea is that if we do that successfully, then the ML empowered products would benefit a lot of users, and it would help it would help people do their job better or have a better experience. A lot of it is also that I want to build tools for my fellow developers, right? So that's on the work side. Now, a lot of my machine learning involvement is actually in the open source realm. So in the open source realm, I'm leading a team at OpenMind. It's an organization kind of dedicated towards privacy preserving machine learning, and I specifically focus on kind of the recommender system side of things. As you may know, recommender systems power a lot of what's out there, even under the radar, right? So the news articles you read, when you do search, what is the ranking of the search results? Items that you're suggested that are showing up on your suggestion list or your feeds for media you consume or items you might want to buy or books you want to read and things like that. So it's one of those technologies that are it's very deeply embedded in our lives, and very subtly, so people may not realize, oh, AI is already everywhere in our lives, right? And obviously, a huge part of the challenge is that we're using people's private information to learn more about them, so we can recommend things that are better fit for them. But then the algorithm doesn't know the person well enough to optimize for things like their well-being or what they actually want to become. They just observe your behavior and give you more of that, right? So that's also like a very interesting field that I'm doing a lot of work in. Yeah. So in
That's really
general, I
interesting.
think, yeah, I was about to say, in general, the field of machine learning is exciting, high growth, but we suffer from some like diversity and balance and fairness and those kind of things. So that's an area that I really care about. I'm trying to work on kind of improving. So transparency, interpretability, fairness, and making AI more accessible for everyone, whether you're in tech or you're not, even if you're just a curious person or just a general consumer. But yeah.
Yeah, definitely. And I have some more questions about AI that I wanted to hit on again in a little bit. But I
Yeah, go
really
for it.
appreciate you talking about the recommender systems, because that's something that I know we've all seen, like
Yeah.
everywhere, right? And it's always been, I mean, people joke about it, right? You hovered over something for too many seconds on Facebook or Instagram, and now that's all you ever see, all these videos or whatever. And it's like,
Right.
oh, come on, I don't even want to see this anymore. How does it know all of this stuff about me? And obviously, it's driven by AI algorithms. But there's always a lot of questions about where is that creepy line, right, between serving up stuff that we really are interested in and knowing too much about me, right?
Yes. Yes. Yep. No, that's a really good question. I think it fundamentally comes down to the exchange of value and trust, right? So until fairly recently, and this is something actually Apple has kind of been leading the field a little bit, a consumer data just taken for granted, right? You just read a giant, disclosure, and somehow they have access to the data you didn't even know. You're not even necessarily aware that they had, and then they use that data to kind of like either make you click on things, make you buy things, and that's kind of how it's always been. But when you really think about it, the revenue generated from consumer data shouldn't that be somewhat responsibly used for the benefit of the consumer, right? So if you're using consumer data to improve your product, maybe that consumer should be paid, right? Or maybe you should only be using that data to help the consumer achieve their own goals, right? So for example, if I'm trying to learn a new language, and you're showing me things related to that language, it is helping serve my goal. But if one day I accidentally clicked on rubber duckies, and now my feed is full of rubber duckies, that's not really serving my goal, and maybe like distracting me from the things I'm trying to get to. So maybe that's not so good, right? So if I'm providing data to a company, I'm hoping that there is some value in exchange. And the interesting part of machine learning right now is that how do we control access, how do we make sure models are trained respecting kind of privacy preferences, how do we even as consumers communicate those privacy preferences to algorithms or companies, but also how could it be used for like something better than just more clicks, right? Yeah.
Yeah, that's a good point. And I know that there's lots of other issues out there related to AI, like judgment calls and structural biases in the training models, and digital colonization is a big thing in the indigenous communities that I work in. What's
Absolutely.
your take on these, the AI issues, and where is the industry going? Are companies working to mitigate some of those, or are companies more driven on the revenues and never mind the issues, we'll deal with that later? What do you think?
Yeah, really good point. So, as a person who's kind of like a little bit unusual that works in AI, I mean, unusual in the sense that like I'm a self-taught programmer and also I'm a like visual minority. I'm a woman, blah blah blah, all kinds of things, right? Like it's a little bit unusual. So, because of that, probably due to pure selfishness, I'm a little more attuned to those issues, right? And that brings me to a point where I think the key to making AI like in the service of more humanity and in the service of our communities is to have fair engagement and representation. right? If there's like a diverse representation of people from different communities, different like intersectional groups working in AI, then chances are we're able to catch problems earlier, right? Because I cannot imagine like what AI might or may not do to the benefit or detriment of someone that's from Hawaii, because I haven't lived there. So it's that kind of thing. So diversity from the perspective of like having the right representation of people working on it, engaging in it, is very important. Now, the thing that's a little bit tricky about AI is that to really effectively engage, the barrier of entry is actually fairly high, right? So either you need to be a programmer, or you need to be good at math, or you need to like be working with the right group, the right companies. You need to be like at a university working as a researcher, and that's not necessarily to our benefit. And also, those are not necessarily true assumptions. So, for example, I can like I have a hypothesis that if you can visualize or somehow make the results of models more interpretable, and also make the training data of these models more interpretable, then people who are interested and motivated may be able to just look at that data and say, hey, I think this data set might be imbalanced in this way and may lead the model to make such and such biased decision. Right. In fact, if I give you this test data and I put that into the model, the bias is very obvious and we don't like this. This is maybe not correct. Right. So kind of working on the human computer interaction or interface layer, and making transparency and all those things more the forefront of research will be helpful for those things. Now you asked the question about what are the companies doing and why or why not are they doing enough, right? um in the end, like we have to vote with our dollars and with our like online presence and with our fees. So it's actually been fairly interesting. Apple has been kind of a little bit ahead of the game on the privacy side of things. For example, they now give you the choice in the app of like, oh, do you want to share this data or not, right? Whereas previously it was defaultly assumed that, oh, you do want to share this data with the app developers. And because
Whether
of
you
that,
do or not, right?
exactly, right? Oh, we're just gonna make this assumption that's to our benefit, and we're seeing a little bit more of like a consumer kind of like favoring that kind of protection, and also they're also starting to lead a little bit even in the ads kind of like advertising realm, right? So the exact details I don't have clear numbers on, so I won't elucidate, and I encourage you all to do that research. But basically, it's saying that um, when they actually give consumer the choice of whether they want to share information or not, the old models where tech companies or developers or whoever or the people who control the power automatically assume that I do obviously always have access to this information no longer work as well, because that assumption is no longer true. And therefore they're having to adapt, and they're seeing some kind of dropping revenue from the ad exchanges, and they have to adapt to this new paradigm. But this is where I encourage consumers like us to be very vocal about this, and just like put it out there. We prefer this. This is where we're putting our money, and I encourage the companies to kind of think a little bit ahead of the game. Right? Don't only update your algorithms until you're pushed and you have to. Then you're behind the game. Right? Think about what do the consumers really want and how can we do better for them. Develop algorithms that are fair, transparent, privacy preserving, and use that to get ahead. Right? Once again, the exchange of data and privacy is value based. Like prove that you have value by using the consumer's data, by helping them accomplish their goals, and then maybe earn that data, right, for the duration that you're being valuable. So those are the kind of things that I think would be like very helpful. But
Yeah.
companies are companies, and they have a bottom line. So a lot of it is going to have to be consumer driven. In terms of regulation, like I think there's a lot of privacy preserving regulations coming out, and that's great. However, it tends to take quite a while, and also they're not always updated on the newest and latest technology. So I see that as a kind of like a lagging measurement, almost a little bit. But yeah.
Yeah, voting with the dollars. I think what that little bit you said, I think that's really powerful because as
Yeah.
consumers, we do have a choice always, but sometimes that information of, how are companies using data, where are they sourcing their data, it's not always easy to find. It's buried in the end user license agreement, right? The stuff we scroll through really fast. You have to go looking for it. And I think it starts with the desire for consumers to recognize what some of the issues are and how data may be negatively impacting marginalized communities, particularly. Um,
Exactly. And this brings me to like an interesting point. So I'm just about to start a project with the Mozilla Trusting AI kind of a working group, and I'm kind of working on open source project to test my assumptions. Right. My assumption, as I stated, was if you expose the results of models and the training data and just make it visual. Right. This is the distribution, for this sub intersection of your data, and this is the distribution for the other intersection. Does this difference look biased, or does this difference look like explainable, right? I think a lot of us can reason about something visual, and we can have a tangible kind of like back and forth with the model, right? Hey, if I put in these numbers, what does it say? If I put in these numbers, what does it say? This doesn't require the company to expose IP by sharing their models, because this is all covered behind a secure API.
sure.
But some of the training data can be exposed because data is data. We can de-anonymize it. So I think by doing this may give people like a sense of like how AI impacts things and how brittle sometimes AI models are. And to add on to that, I'm kind of working on a set of courses that talks about some of the bias in choosing AI and how it impacts people in the real world. And also, if you wanted to put on the hat of a AI bias bounty hunter, what would you look for and what would you do? How do you look at these charts and ask yourself the right question to see if something is weird going on here, right? And by doing so, I'm hoping to kind of provide the tools and also some knowledge and some like motivating examples, and hopefully get like a lot of community interest, so we can all be kind of like bias bug hunters, right? And yeah,
I like
hopefully it
that.
goes well. But feel free to check it out. The project is called Bountiful Future, and we're starting a working group with Mozilla for people who are interested in trustworthy AI or interpretable AI or AI activism, or just interested in learning how AI currently might affect our own communities. Like, would definitely love to have you get involved. And if you're a company that has like a use case where you have a model, you're like, we're about to deploy this, but we would love some, free tire kicking on this. That's also a good way to work with us. But yeah.
That's really great. Can you share the URL for that in our chat?
Yeah, let me see if I can look that up. So,
I'm just like asking you on the spot.
yeah,
Just in case folks might want to know.
this is
And while
definitely
she's
not
doing
a
that,
trend.
and if anybody, I know we've got several folks here that have joined us. So if anybody has any questions for Maddie as we're having a conversation, feel free to drop them in the chat as well.
And I'll drop my LinkedIn contacts as well in case you're interested in about the projects you want to get in contact. All right.
Thank you so much. Awesome.
Yeah.
So last week we talked a little bit about how machine learning can be used to help find solutions for really big issues. And I kind of challenged our group to think about that over this past week about what are some of the really big issues out there. I mean, the world's full of issues, right? But what are the ones that are meaningful to us individually? And how might we use machine learning eventually, to try to tackle some of those issues? How do you break down a really big issue into smaller steps that could potentially be analyzed or solved through machine learning and AI? What's your take on that? What are some of the big issues that keep you awake at night with your data scientist mind to think about how machine learning or AI models might be able to tackle some of those big things?
Yeah, so there are a few kind of like existential things going on, and AI safety and transparency and like ethicalness is like actually one of them. Because the nature of AI is that it will kind of scale at a rate that humans are not intuitively used to, right? So
Mm,
AI and kind of silicon scales exponentially, and humans so far we've kind of evolved more on a linear scale, right?
sure.
So by intuition, I think we are likely to underestimate how quickly things will change and things will kind of like progress. So that's one thing. The other thing that really worries me is climate change and things happening in the environment. So like AI for climate change has definitely been a more popular topic these days, but I don't think it has the amount of like funding or resources allocated to it as some other fields like recommender systems, because people can make more money from that.
Sure.
Part of the issue with climate change is that also like the data is very difficult, right? So as many of us may know, if you want to have a productive and good model, you need to have good, high quality, consistent, and clean data. And a lot of data we have collected about the environment is kind of like centralized to certain locations and only certain fields. There's a lot of information missing about microclimates, but I know there's a few kind of like DIY home kits for like for farms or IoT or those weather stations, and those data is like probably a really good hidden resource for studying that. That's kind of like the main things I think about. But when I think about like solving a big problem with AI, that's sometimes a tricky premises because first of all, you're kind of like already specifying the solution. A lot of times, the solution is not AI. The solution is that leaders of the world needs to not play this this like bad game theory kind of game and just collaborate and work together and actually putting resources to solve the problem. But if you're trying to solve a big problem in AI, I would just say, break down the problem and figure out what is the most valuable difference, right? If I can fix this one piece, then that will kind of make the whole thing a lot better. And what is that most valuable piece? And can I frame it into a AI kind of problem? So usually when that happens, I ask myself the question: is there enough data? What is the simplest algorithm I can validate that will be able to like see if it's even kind of like useful or not, and then I go from there. Like you always have to start very very small. It's very easy to overcomplicate things in AI and build a large big model that seems to work but actually isn't very useful, and you spend like so much time debugging, so much time on the compute. It's better to like start very small and just like build it up from there. Yeah.
I could tell that was from experience, as you're able to share
Yeah.
how that can scale up and not even be helpful.
Yeah.
Yeah, thank you. So next week, and in the next couple of weeks, we're going to be talking more about deep learning models themselves, getting more away from the machine learning side and into the AI side, even though those are related. And I know that you said you had some slides that talk a little bit about what that deep learning might look like, or what that path might look like for us. Did you want to share?
Yeah, so I can actually talk about two things related to that, and this is something like I'm happy to like listen to audience feedback on, right? So I can talk about like the different career paths in like data science and machine learning and AI in general, and what are the skills you need to get to these different positions, and also like what is that job really about, right? What is you doing a good job versus like what is the day-to-day work. Or I can actually go through like a very quick, like non-scary, not messy, like visual crash course of deep learning, just so you can have like a bit of intuition when you approach like kind of the deep learning realm, right? So I wonder like what will be most useful for people. If not, then I'll just defer to you. So you let me know what will be most interesting. It happens to be in the same slide deck, so it's easy for me to switch around.
All right, folks who are here, are you more interested in looking at career paths that are related to data science, machine learning, and AI, or are you more interested in looking at some visuals about deep learning? Go ahead and drop
And
your
getting like an
thoughts in the chat.
intuition, like a crash course.
Yes. See, honestly, like you said earlier, everyone relates to visual. I'm like, yeah, totally. Let's see what you have in mind.
Okay.
Yeah,
Yeah.
Brian says
What
visuals
votes?
also.
Okay. All right. That's
Maybe a
two
little bit of
votes.
both.
Okay. Okay. I think by this point, we have 7 people. That's enough votes to roll with that. So let's do that real quick. I'm gonna attempt to share my screen. Oh, Ben's open-minded. Yeah. I can share the slides with you after Ben, so you can check out the other stuff too. So this is a crash course. It's meant to give you a little bit of intuition, and I am actually gonna also share my face. And I think most people here, like if you remember your like elementary math training, you understand what linear regression is, right? So I'll take you from linear regression, like drawing a line of best fit a equals or y equals ax plus b, all the way to neural networks and how machines learn, right? Just so you have some kind of like mental reference for what's going on there. So this is where we start. Line fitting or curve fitting. you have a bunch of dots and you're trying to find the parameter for M, which is usually the scope, and B, which is the interface, right? So far, so good. Everyone knows how this works. So then what are we doing next to go towards neural networks? Well, we're trying to find the line best fit. So then the question is, how do we define best? What does best mean, right? So this is what this image is showing. You're basically trying to get the closest distance between your line and also your data points, which are the red dots, right? So if you add up the distances of the green arrows, you want to make that as low as possible, right? So obviously, sometimes if you get the line closer to some points, for example, if you shifted this line up towards the higher row of data points, you're going to be further away from the lower row of data points, right? So you kind of want to be in the middle, closer to as many points as possible. So this is the only kind of formula in this equation. This is basically what the error is in most kind of like regression problems, right? So you take your data point and you minus the value, which is represented by the line, and then you have to square it. Why do you have to square it? Because you don't want the negative differences and positive difference to cancel out, right? So let's say you're guessing a number and you're 10 under for one, you're 10 over for the other. Your error is actually 20, but if you don't square it, you're going to end up with like a zero error, and you think your model is guessing perfectly, but it's not, right? So once you square the errors, then you can sum it all up. So basically, just exactly what I said, you add up the distances of the green arrows, and you want to minimize the distance of all the green arrows. So hopefully that's so far so good. So then let's ramp it up a notch and go to plane fitting, right? So previously we're on a kind of like a 2D plane. We had the X and the Y. So now we're just going to add one more dimension, and we're going to make a depth dimension. Just imagine a dimension going into the screen and coming out of the screen. So let's call that Z, right? But you will kind of start to see that the process is the same. You're changing the parameters of the slopes on the different directions, and you're also now changing the intercept, but just on multiple dimensions now, right? So hopefully it's not too much of a jump to go from fitting a line to fitting a plane. You just have one more dimension. So I want to see if there's any like questions so far. Hopefully, like so far so good. And feel free to stop me anytime and ask any questions. Okay, so now we're fitting planes, and that's awesome. So I now want to explain how neural networks is actually under the hood doing a bunch of regressions in a sequential chain, right? So this is what we call like a neural network diagram. You've probably seen this before. And each of the nodes is what we call quote unquote a neuron, right? So I just kind of have a exploded view of one of those neurons. So I want you to look at this smaller diagram carefully, and I want to prove to you that this is basically just regression with a small difference. So one unit of a neural network is a perceptron or a neuron, and honestly, that is just curve fitting. And here's the proof, right? So once again, you have a bunch of data, which is the axis, and sometimes it's higher dimensional, so it's not just a number, it's not a vector, it's a matrix, right? But then you still have to figure out the weight for the slope. So that's what the W's are. Think of the W as a slope, but it's a vector, higher dimensional vector, that represents multiple different directions, right? You still have a Y. You're still trying to basically predict as closely as possible what the final value to be. You're still guessing for that value, and you still have a bias, right? And then you'll see that in the middle of this kind of neural network diagram or perceptron diagram, you see a summation. So it's exactly the same thing. We add the biases that we guessed and the slope that we guessed, and we're trying to get to a y. And we want that y to be as close as the actual value, right? So basically, there you go. There's your kind of your bias. The x's are still the x's. The slopes are the w's, and we're gonna add it, and you get a y, right? Now, the only tricky thing about a neural network is that it's a bunch of regressions chained together. So the result of the first neuron gets fed into the neurons of the next layer potentially, right? So people can stare at this a little bit longer, but trust me, this is honestly how a neural network is doing. Now I'm gonna kind of give you the difference between just regressions and neural network, and that is the activation function. The way I like to explain this is that, if you draw me kind of on the equator and you pointed me straight towards, towards the east direction, and you're like, okay, Maddie, start walking, but I want you to get to the North Pole. You're not allowed to make any turns. So then I'll be sad because I'll just be walking in circles around the equator because I'm not able to make any turns. But if you're saying, okay, so I want you to start on the equator, but you can make turns, then I can get to anywhere in the world because I can, leave that like line on the equator, right? So to make a neural network more expressive and be able to have more power than just a chain of regressions, you have to add a nonlinearity, which is essentially the turn in my analogy. And this is a set of potential activation functions, or nonlinearities, as they're also called, very fittingly. So you can basically cover more of the space that the model should be able to should be able to express, right? So once again, we went from just regression chain together with a nonlinearity between the layers, and now you basically have most elements in a neural network. So then I want to cover kind of like fundamentally how this neural network situation actually works, and it has to do with something called the universal approximation theorem, right? So there's definitely a mathematical proof that we're not going to go over today, but basically what this theorem says is that you can get arbitrarily precise answers to almost everything if you just add enough parameters and if you just add enough neurons, right? So, for example, if I wanted to guess someone's income, and I'm only allowed to ask one question, which is like how old they are, right? Based on that piece of information, I can only guess so well. But if I can ask also like, did they go to university or not, or where do they currently live, then by adding more information, adding more neurons into the neural network, I can get closer and closer answers to how much someone's income is. So that's kind of how this ideas work, how the theorem works. But there's also a visual representation of this, right? Imagine you're trying to approximate a surface like someone's face or someone's hand holding a pen. If in the same area you only have 4 pins, you're gonna have a very very bad time having a very good representation of what this person's face looks like or what the object looks like. But if you have smaller and smaller and more of these pins in that same area, you can do a better job of approximating the underlying surface, right? So that's kind of how neural networks work, and why frequently you see having more parameters leads to better performing and more accurate neural networks. Now, there's a downside to that, and that is to estimate each of the parameters in the network, you need a few data points to be able to make that estimate well, right? So if the first person or first bird I saw was blue, and that's the only example of a bird, I might be prone to think that all birds are blue, even though if I see more examples, I'll know, okay, the color is not always like that, right? So for each parameter you want to fit, you're going to need a lot more data. And sometimes you don't have enough data. Therefore, your neural network, even though it's very big and very powerful, it actually doesn't learn effectively and it actually doesn't perform well. So then we are kind of going to talk about how machine learning works, right? So we talked about these, parameters. We talk about we're trying to learn the weights, we're trying to learn a slope for the regression, we're trying to learn a parameter for the intercept. So how does the neural network learn? And this is just like how humans learn. We're trying to take small steps in the right direction, right? So here is a visualization of a curve being fitted, and also what the air surface looks like, right? Remember how we're trying to approximate that person holding a pen. So just imagine that is the surface that we're trying to make a function approximate. And as you can see, if you move the ball in certain directions and each of the direction represents a parameter, you can actually get the line to fit better, right? So just imagine the bias as, the y equals mx plus b, the b in that formula that you're trying to find the number of, and then imagine the weight as the w in that formula, right? By changing the value of those parameters, you can actually get a line to fit much, much better. So machine learning is really all about taking small steps in the right direction. So then the next question is, what is the best direction, right? What is the right direction? And for that, it takes something called partial differentiation. So sounds scary, but really what you're doing is if you're trying to figure out along one dimension in what's where you should you move left or right or forward or backwards in that one dimension only, you basically just take a slice of that shape, which is 3D, and you just look at that little line. um, so as you can see, by changing the value of x, now x is sliding more towards the front of the screen, you can actually change the arrow in which the arrow that represents the value on the surface, right? So when you get to the top, it's going to change directions. And if you're trying to reduce your error, you kind of want to keep going in this direction, and the arrow will point more and more down, right? So this is how machines learn, and this is what we call gradient descent. You're basically doing partial differentiation along all the parameters and trying to figure out in what direction do I need to change this parameter, do I need to change this weight, do I increase the slope, do I decrease the slope, and also by how much, right? So that was an easy shape, and everything's fun in games until you see something like this. Then what do? This is where I do that phase, and this is also where I use a tool like TensorFlow, right? So TensorFlow is open. Well, I think it's open source, but it was originally packaged, kind of like created by Google. And what it does is that it does automatic differentiation. So when you have a crazy shape like this, you don't have to cry, you don't have to do a lot of math. You just give it to TensorFlow, and it will figure out what is the right direction, right? So this is my super quick crash course on kind of like visualizing how machine learning works, and like taking you all the way from something that most people kind of have an understanding of, which is linear regression, to deep learning. That was super quick. I'm happy to go over any of the specific details or answer any of your questions in general.
That was amazing. And I have to confess, scary looking, as a non mathematical person. But I know that we are going to be learning a little bit about TensorFlow, and I'm really excited to learn TensorFlow. So it was really helpful to see in your demonstration how TensorFlow can handle those kinds of things. I guess handle it for you, I hope. So I was really
Yep.
interested in that. Thank you so much.
Awesome.
So, um, what would be some tips for people that are trying to get into a career in this field? Or just really briefly, what are some of the different kinds of career paths that somebody might think about if they were thinking about changing careers from whatever they're doing now into something that's more AI or ML minded?
Yeah, so I think, the first thing I'll say is that the difference between like being a programmer or a developer and being a machine learning engineer is actually like fairly small, right? At the minimum, it just requires like an interest and some like willingness to sit and grok with the mathematics a little bit, and writing lots of tests for yourself, because sometimes you don't know if you're going the right direction or if it's working or not, and being like willing to learn the new packages and the new technologies, right? It's actually a lot less about the math, which is the scary part for a lot of people, than being reasonable and asking yourself like, you know does this make common sense? Like, does this seem right? For example, if you get a result that's like extremely good, then you may ask yourself, hey, am I leaking the data somehow? And when we say leaking the data, it just means that somehow, when you're testing your model, you basically ask the exact same question that you used to train the model with, and therefore it's remembering and not learning, right? It's kind of like memorizing and not like learning a new skill. So I think the other key thing I would say about approaching machine learning and trying to get into the field is that the best thing you can do for yourself is just to build projects, right? Just like learning anything engineering or learning any kind of new technology, actually getting hands on is very important. And so the process I would recommend there is that see if you have any personal interest, maybe your hobby or something, and see if you can find a data set related to that, right? Um, just use pandas or numpy and draw some graphs about this data, explore the data yourself, and then ask yourself, okay, what kind of question can I try and make a machine learning model answer with this data set, right? So then you can basically use that to guide your kind of like self-directed study. The good news is for most of the machine learning things you need to learn, there's like amazing amount of like probably too much amount of amazing good resources online. So pretty much anything you want to learn, there is some resource for you out there. So the question is like, how do you keep yourself motivated, and how do you keep yourself interested, and how do you like guard against the fatigue of like tutorial after tutorial and blog after blog and not making progress? And honestly, the answer is just to build something for yourself, build your own projects. It doesn't need to be part of your portfolio. If it doesn't work, you don't need to show it to anybody. But usually, if you're building something that's out of your personal interest, something you have a deep understanding of, you actually do succeed because it's kind of fun, right? So yeah, those are the kind of the key things I would kind of like mention to help you get started.
Thank you so much. I really appreciate having you join us today. Does anybody have any chats for Maddie? I haven't seen anything in the chat, but before she goes, okay, so Brian says, what do you see is at the intersection of AI and blockchain and Web3 career wise?
Yeah, so this is a very interesting question and something I actually like think a lot about. These two technologies will 100% merge, right? It's only a matter of time. And funny enough, the barrier to entry to getting into machine learning versus getting into blockchain is about the same. It's actually lower than what people would expect, right? So one direction of looking at this is that there's like a vast amount of data produced by the blockchain space or Web3 that you could be expert of analyzing, right? So when we think about what does it mean to be a good data scientist? Actually, let me show you a slide about that. I'm gonna share my screen again. Hopefully it works. Okay, so I'm gonna go all the way back. Pardon the all the like screen changes. Okay, so this is my definition of a data scientist, right? You take some data, you write some code around it, you maybe do a little bit of ML, you find some interesting things, and you communicate that. So you're trying to make, you're trying to generate impact from the data, right? So if you're a good data scientist, you have created business value from data. So if you want to be a Web3 data scientist, for example, right, then you kind of need to know certain things about the blockchain just so you can have a tangible understanding of what you're even looking at. And you need to figure out how to help people solve problems in the blockchain space, right? One of the key things is that how do you prevent fraud? How do you prevent network congestion? How do you kind of make transactions more efficient? Algorithms to route transactions more effectively. So those are all things that are option, right? And the other option is let me stop sharing now. The other option is like how does machine learning and blockchain technology play together, right? So for those who are kind of following the space, there is a kind of blockchain or technology or a protocol called Ethereum. And what Ethereum does and why it's different than the first generation blockchain, which what is like what I consider Bitcoin, is that Ethereum is actually a virtual computer, right? So it's capable of doing decentralized compute. Now the other interesting thing about the blockchain is that data is in most cases kind of like generally synced all across, right? So you have decentralized data, you have decentralized compute. Could you do decentralized machine learning? And the answer is yes. So the field that tends towards decentralized machine learning is actually federated learning, where you're doing computation at the edge or on like remote locations, and you're slowly aggregating the results together, right? It's kind of like uh, asking Crystal to guess, what is the gas price going to be tomorrow, making a prediction, asking me in Alberta, making a prediction. And if we both agree the price of gas is going up, then that's probably likely to be true, right? So it's a little bit like that. But there are many options, and these two fields are most likely to merge. So I think starting as a data scientist specializing in blockchain data is probably one of the easiest past the entry. But the most interesting one is that maybe like decentralized machine learning and new algorithms that working kind of like uh, in the setting where you don't have a central trusted aggregator, right? But yeah, long, long, long answer, but I really like that question.
That's
Um,
great. And Brian says that's great info as he's pursuing learning both at the same time. And thank you so much for sharing. Aditi
Awesome.
asks, she has a question. Although this itself requires specialization, we could still try and learn about training models using different packages and libraries like TensorFlow. But I personally, she says, like she continues, I personally find the deployment part more difficult or more real world application oriented, because once you train your model, how do you combine that pipeline with the software for people to use it? And that's a great question. How do you create that pipeline for people to use the models that you create?
Absolutely, that's a amazing question because frequently even even as someone that works in industry, I struggle with, oh, like we have this cool algorithm now, it's so cool, like, but who cares about it and who's going to use it and how do we even get in front of people, right? And then sometimes that's when like everyone's sad because the engineering efforts are like very very difficult and non-trivial. So this is where like I recommend kind of like pretend that you don't even know about machine learning and think like an engineer, right? So I'm gonna talk a little bit about something I call the machine learning model like lifecycle. And if you're a web developer, this will be a very familiar analogy, right? So you have CRUD, you have create, read, update, and delete. That happens to be the same thing that a model needs to be able to do, right? You need to be able to create a model, and you need to be able to read results from the model. You need to be able to update the model because, as we know, more data means better model usually, and also your data becomes stale, right? So if I train a model using gas prices from 2 months ago, that's not gonna be very useful right now. And
Not right
also
now.
sometimes exactly, and sometimes models go wrong. So how do you delete the model to make sure it's not causing havoc in the real world, causing harm? For example, like sometimes unintentional consequences only come out after you deploy it. But how do you kind of like limit damage? And also sometimes you make a mistake, right? Your new version of the model that you think is going to go to do super well doesn't actually do super well. How do you revert back to your old one, right? So I would recommend you think about that. But even beyond a like production deployment kind of setting, it's very important to think about how machine learning algorithms interact with the other parts of the world that it needs to interact with, right? So, for example, how does it interact with the rest of the engineering system? How does it interact with a human that's kind of in the loop, like a human consumer? So, thinking about those things before you get all excited and start working on a cool model that doesn't actually work well in your application is very important. So this is often where having domain expertise is very valuable. Let's say you're very very deeply like ingrained in certain like field of science, or even like as a retail analyst, knowing things about your domain will help you build a more productive and more useful and more widely adopted machine learning application. But what I recommend is actually using tools like Streamlit, and I'll type that like thing in Streamlit. So this is a kind of a tool that allows you to build a front end interface for your machine learning algorithm, basically straight from your Jupyter notebook, right? Uh, was very minimal, kind of like needing to know how to do like JavaScript or front end stuff, because oh no, it's like one more thing you have to learn, right? And I would recommend build a simple model and get a Streamlit front end going, and then just ask people to play around with your model and see what they think, right? And then so if should that be successful, then you can think about how do I pipe the results of this model into the front end of actual application. Like where does this prediction need to show up, right? Maybe so take the example of like a app like Gas Buddy. I have no affiliations with them, but I use it quite a lot because I drive around a lot. Um, let's say they build an algorithm to predict gas prices by looking at the routes you're about to take. It may be able to say, hey, like I know you filled up right here, and this is the gas tank amount of your truck, and I know you're about halfway done. So where you're going, the gas prices will actually be higher, and by the time you get there in a day or two, the gas prices will be higher. Maybe you should fill up now, right? So that kind of thing. So then the question is like, do I get an alert? Does it show me the predicted value along my routes? Like, what is the best way for the consumer to interact with that data? So that's kind of questions and things you should think about. But try Streamlit. I've been having a lot of fun with it.
Thank you. What a great suggestion. And that was Streamlit. And I know that our next speaker, we're going to be skipping next week for the workshop, but our speaker for week 4, Gabriel. He's going to be talking specifically about how to get an ML project from idea all the way through to deployment. So that's going to be a really important one to make sure that you catch for week number 4. Really excited about that one. Maddie, again, thank you so much. I'm going to just share my screen here. We have a couple more things just to wrap up with before the end of our little hour here. We again have been working in Kaggle. This whole month we're working in Kaggle. If you haven't had a chance yet to start in Kaggle, that was at kaggle.com. You can just head over there, create an account. It's completely free. And these are the topics that we've been working on this month. This week, we are wrapping up the course on pandas. So all of the stuff that Maddie was just talking about when it comes down to making sure that your data is clean and how to deal with gaps in your data and just learning how to use pandas and NumPy, all of that is covered in this course. So if you aren't sure what she was talking about exactly, no problem. Just, start at the beginning. Take it easy, take it slow. It's really easy to work through the lessons. They're very easy. I've been having a lot of fun doing Kaggle, and we're just going to go straight through through as much as we can for this month, and then of course you can continue learning on your own. Next week, we are going to be focusing on intermediate machine learning, that course specifically, which is going to dive deeper. That course is going to be diving deeper into some of the concepts that Maddie was illustrating for us today. And if you have extra time, you can also look at feature engineering and time series regression models. That'll be really relevant to some of the work that we're going to be doing later on. And then week 4 is when we actually get into TensorFlow and start looking at the actual concepts of deep learning, AI, all of those really cool things. So if you haven't been to Kaggle yet, jump over there and do that. Try to find some time to work on it. The lessons are short, I promise. And Maddie, as she dropped in the comments, Kaggle is also a great a place to find really fun and interesting data sets, project ideas. There's really fun challenges. There's lots of cool stuff to do. So definitely spend some time over there in Kaggle. It's really interesting. And again, week 4, that's going to be on September 30th. So 2 weeks from today, we're going to be hearing from Gabriel Casimiro. He's going to be joining us from Brazil, and he is a data scientist at Falconi and also a Google developer expert on the TensorFlow team. So all of our TensorFlow questions, Gabriel's going to be able to dive in deeper on some of those. So we'll do that in 2 weeks. And then before we go, let me share the correct screen with our little spinning wheel. I shared it last time, but I wasn't sharing it because I have to share the tab, right? So here's our spinning wheel. We only have a few people that were able to join us today. So the odds are 25% you're going to win a prize. Let's go ahead and spin this wheel and see who our lucky winner is for this week. Suchandra, by a hair, you are the winner for this week. Congratulations. So I have some prize packages you can choose from. I know that was really close. Sorry about that, Brian. But we do have a prize package for this week. Please send me your email address, drop it in the chat, or message me on Slack so that I can give you the prize form that you can fill out so that you can claim your prizes for this week. Brian, join us next time so that you can have a chance to win. I know winning, I love winning fun stuff. So looking forward to doing that. And we are just about at 5 minutes to the hour. Are there any last questions before we go? All right. Thank you again so much. That was a lot of fun. Brian says, thank you. This was awesome. This was totally awesome. Thank you so much, Maddie, for being here. And thank you, everybody, for joining us. This is going to be, again, we're going to drop the link into our YouTube channel. So if you had friends that didn't get a chance to see it, please share the link with them. Don't forget to RSVP for the next session on September 30th. I know some of you had trouble joining today because our tickets actually closed at noon. So make sure you get your ticket so that you can join that event later on. Okay. And we are good to go. Thank you, everybody. Have a great rest of your day today, a wonderful weekend. I like to try to finish on time so you can get a snack before you have to get back to your desk. So thank you so much, everybody. Happy learning.
And thank you, Krista. Peace.